So in this video, we will deal more with the Grand Canonical Ensembles. Basically, we will try to understand our couple of videos. How can we connect the thermodynamics and the statistical parameters through a Grand Canonical Ensemble formalisms. So a system in Grand Canonical Ensemble is what we will be dealing today. So till now we know the expression for PRS. So PRS is the probability for an element within an ensemble to have an energy ES and number of particles NR. So the expression which we wrote was PRS is equal to exponential minus alpha NR minus beta ES divided by sum over RS exponential minus alpha NR minus beta ES. So we learned up to that point. So now let's continue with the same kind of derivation which we did for the canonical ensemble. So there, if you remember, we imagined an ensemble system which is divided into script n number of identical elements, right? For example, so 1, 2, 3, and so we have up to script n number of, it is divided into script n number of identical elements. And these elements are are labeled as 1, 2, 3 up to script n, and this whole thing is in a Grand Canonical Ensemble. Okay. So now let's imagine that NRS. So NRS is the number of elements with the number of elements with the NR number of particles and ES energy at set time t. So what all relations you can write in that connection? So one of them is that sum over NRS. What will be that number? So NRS is basically a number of elements with NR number of particles and ES energy at time t. So at the other time also I told you that NR and ES are actually variable numbers. So for various you have to define the NR and ES with respect to element, right? So sum over NRS is equal to what? Script n, right? Sum over NRS is equal to script n. And therefore I can write sum over NRS into NR. I can write it as script n into n bar, where n bar is the is the average number of particles, right? N bar is the average number of particles in an average number of particles in elements of a system, right? Similarly, you can define E bar also. E bar is the average energy, right? So now we know the expression for the PRS, right? So this is the expression for the PRS. I can always write N bar is equal to sum over R and the RS NR into PRS, right? Because PRS is the probability of having a system with having an element with NR number of particles. So N bar can be written as summation over NR divided by the whole number, actually, right? So whole number of elements, which is actually can be written as PRS also. So therefore, sum over RS NR into exponential minus alpha NR minus beta ES divided by sum over RS exponential minus alpha NR minus beta ES, right? Which obviously I can write this one as in terms of the differential with respect to alpha. So I can write this as minus dou by dou alpha of ln summation over RS exponential minus alpha NR minus beta ES, right? So these are two equivalent expressions, minus dou by dou alpha of. Similarly, E bar, which is the average energy, can be expressed as sum over RS ES into exponential minus alpha NR minus beta ES divided by sum over RS exponential minus alpha NR minus beta ES, right? So this can be expressed as in terms of the differential with respect to beta minus dou by dou beta of ln sum over RS exponential minus alpha NR minus beta ES, right? So now we have the expression for the N bar and the E bar. Okay. So we will continue in the next video.